He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
I do think that community is and has to be at the heart of this project, because if there's no social licence, if there's no community interest in the fact that we're losing these seaweed forests, then there's really no pathway to influencing decision makers, people who have research grants. You know, we need our community to actually also be really engaged with what's happening in their harbour and to care enough to, you know, add their voices to that and to understand what we're losing.
Kia ora, nau mai haramai ki te ao hurahanga. Hello and welcome to Our Changing World. Ko Concannon tēnei. That's the voice of Zoe Studd. She's co-director of Mountains to Sea Wellington and the project lead for Love Rimurimu.
Love Rimurimu is working on regenerating Wellington's ocean forests. We began with an education program called Love Rimurimu. We delivered that with a number of schools, taking them snorkelling, talking to seaweed experts, trying to create sort of different products from seaweeds as well, so looking at kai or fertilisers or bioplastics. And through that education program, you know, some of the students we've been working with from Te Kura Kaupapa Māori o ngā mokopuna, who are here on the Miramar Peninsula in Motokairangi, they said, well, let's start trying to grow some seaweeds inside our harbour. So that really then kicked off the pathway to us looking at restoration.
We're standing near the boat club at Werser Bay, Hutia Kakariki, on Wellington's Miramar Peninsula, Te Motokairangi. This is where the action will be happening.
Today we've got some seaweeds that are coming from Niwa, and those seaweeds are being blessed by Taranaki Wānui before they get returned to our restoration site here at Werser Bay. And so the aquaculture lead from Niwa is bringing them to the site, and we're meeting here some of the students who have been a part of the restoration project, some of the kaiako from Ngā Mokopuna, and our community science lead, and we're going to be doing some planting out.
The aim is to help the regeneration of seaweed forests in Wellington Harbour. So it's a big collaborative project involving Taranaki Whānui, local kura and community, Niwa and Victoria University of Wellington. But what's up with the seaweed that it needs help? One of the project science leads is Dr. Christopher Cornwall, a senior lecturer based at Victoria University's Coastal Ecology Lab. His research focuses on how climate change and local stressors impact kelp forests. Stressors such as sedimentation, where human activities like clearing trees from slopes higher in the catchment result in sediments entering the harbour.
It makes it really hard for seaweeds to photosynthesise, so they get all their energy from the sun, essentially, a reaction between carbon dioxide and light. And if they don't have enough light, they can't photosynthesise.
Overfishing of urchin predators such as large snapper and crayfish has also meant that at some sites there's an overabundance of urchins, or kinna. These graze on the kelp, munching down existing forests and taking out any new growth. And of course, there's the threat of climate change.
What we're starting to see anecdotally is discussion from community members about how marine heat waves are impacting giant kelp. So there has been some recordings from community members showing that giant kelp canopy cover might be decreasing in years where we have big marine heat waves. We also had a lot of marine heat waves last year, and we've been doing surveys the last 2 years, so we need to look at the data which we just collected this year to determine how the seaweed abundance has been impacted by marine heat waves. But in saying that, we also run experiments down at our Coastal Ecology Lab to determine how things like sedimentation and light and temperature will all impact the different species of kelp.
Now, Macrocystis pyrifera, giant kelp, is not the only seaweed in Wellington Harbour. There are heaps of different species, and we don't know exactly how many, says Christopher. But the dominant species are brown kelps, and the project is focused on them for now.
Kelps are really ecologically important. They're perhaps the most ecologically important marine organism in New Zealand as a group. So giant kelp particularly, but other kelp as well. So they provide both food and habitat to an incredible array of biodiversity. The giant kelp itself is really important because it can alter the amount of light and the wavelength of light that it receives, that other species underneath it receives. It can also alter wave action and nutrient concentrations in seawater. They also take up CO2, so they alter the pH of seawater. Essentially the opposite process of ocean acidification occurs within the kelp beds during the day. So they're really ecologically important. If we were to lose kelp, many spots would be absent of things like paua and other species that we like to eat, like finfish. If you go out spearfishing, you'll notice that blue cod tend to hang around near the giant kelp forest, and that's for a reason, because there's more food there.
There are two streams of research. The first is surveying in the harbour.
We have 6 focal sites that were chosen due to mana whenua interest and scientific merit, and these range from really degraded sites to really almost pristine sites. So what we have at the majority of our sites in the Wellington Harbour is ecosystems that have lost giant kelp and other most big brown seaweeds. So instead what they have are really just the hardiest seaweeds left, or no seaweeds at all, so what we call kinnibarrens. So a mixture of kinnibarrens and degraded seaweed ecosystems. At our better sites, which is probably what most of the harbour looked like pre-human activity, we have things like giant kelp forest, we have lots of crayfish, we have some mussels, lots of paua, etc., and a healthy looking ecosystem, sponges, etc.
And for these different sites, have you been monitoring them across time?
Yeah, so what we've done is a combination of different things. So we've measured temperature and light across these sites through time, and what we've also done is an experiment to test how different stresses could have impacted these sites. So we know from a survey that was done in 1990 by another researcher, Cameron Hay, that there was giant kelp existing in many different places where it's now absent. We also know from our own experience that it has disappeared in some places. So the key question is to determine why it's gone and whether we could restore it and keep it there.
The second stream involves experiments in the lab, where they can control light and temperature levels and simulate the effects of marine heat waves.
What we found in the lab is that light is really important for seaweeds, as we already knew, but that even mild, what we call mild marine heat waves, so temperatures up to about 18 degrees, can have strong negative effects on the giant kelp here in Wellington. Once we get up to 20, 22 degrees, these heat waves start having really dramatic impacts, and at 22 degrees we're seeing almost 50 to 100% mortality depending on the other circumstances for that giant kelp. So these are marine heat waves that certainly will happen in the next sort of 5 to 10 years, if not sooner.
These are big, gnarly problems. Overfishing of urchin predators, sedimentation, climate change. They're not quick fixes. They need to be solved if kelp is to flourish. So, should we be planting out kelp before they're sorted? Zoe explains the thinking.
Some would say wait until we've tidied up the harbour and we've dealt with all the external stresses before we begin a restoration program. However, there are certainly some places in the harbour where we know we can succeed with restoration. And we have to take a dual approach to this. We have to be learning how to restore, which is the kinds of knowledge and techniques we actually haven't developed fully. So we have to be learning as we're also trying to address these much larger scale problems that are around our harbour and that are around our land use and around our water quality issues as well. So I don't think we can wait to fix all of those problems before we begin our efforts in restoration.
Love Rimurimu is a long-term project.
And we are just at the beginning of the restoration efforts. So we did some pilots last year off a raft in Mahanga Bay. This year we secured a 5-year resource consent from the Regional Council, and that means that we are able to, experiment with restoration techniques and species. And so over the next 5 years, this year it's quite small scale, but over the next 5 years we hope to expand into other restoration sites. This year one, we got together with our collaborators, Niwa, Victoria University, Taranaki Wānui, the students that we're working with in community, and we selected a number of pilot restoration sites around Motukairangi. And this site here is where our community and our students have been planting out. There are 2 other restoration research sites that Niwa have been leading in Scorching Bay and Kobe. So this year our pilot sites are varied across those different organisations, and they're very small scale. So we are every year hoping to build on what we learn. So the process will be try things out, build on them, If we have success, expand those efforts, try and learn as much as we can as we go through it. So we're really prepared for this to be a journey of like trial and error and failure and some successes, glimmers here and there, that will kind of lead us on a pathway to fuller restoration.
To help regenerate a forest on land, you need trees to plant out. That means there's a nursery somewhere where dedicated people have figured out how to grow the trees. Someone is putting little seeds into trays, caring for them, watering them, nurturing the seedlings that emerge into baby trees, which then, once big enough, get planted out. In this case, the giant kelp nursery is based in Niwa. So I head along to chat to the team there about how you coax kelp to grow. Well, maybe coax is the wrong word.
We stretch them out. Sometimes it's quite brutal because we put them in a blender, chop it up, mix everything together and put back on the rocks.
Dr. Roberta Darquino is science lead at Niwa for the Love Rimurimu project, and she explains to me the life cycle of giant kelp. We start with an adult giant kelp, grown to several metres in length, attached to the seabed floor by its holdfast. And near this base, the kelp starts to develop some fertile tissue, and inside this, a multitude of spores.
This fertile we call sorai, and inside this sorai, there is a part that you can recognize because they have an oblong shape and they're usually a bit darker and raised, so you can touch them and feel it. So inside this portion, there is the sporangia, and from the sporangia, 1,000 more of spore can come out and develop.
These spores are microscopic, teeny tiny things floating in the ocean, but they develop into either male or female gametophytes. Still teeny, which is why Roberta shows me through a microscope. They're filamentous in this form, which means thread-like, and they clump together in groups of male and female. So to me, they kind of just look like fluff.
Basically, some of these fluff are female and some are male. Yeah, we're growing this in the lab and we induce fertilization, basically.
This is where the blender comes in. By stressing the gametophytes, they trigger them to produce sperm and eggs. Once fertilization has occurred, the cell starts to multiply and grow. This is now the sporophyte stage, which is from baby seaweed fronds all the way up to meters-long adult giant kelp.
But when the sporophyte, that is the large stage, starts to grow and is visible by naked eye, we start to move things to the other lab in the aquarium where we have big tanks.
It smells of the sea in here.
It probably smells of seaweed, kenna and oysters at the moment.
This is the aquarium, and my guide is Niwa Principal Technician Neil Barr. To the right are a series of large, round, black plastic tanks sat on pallets. A large white frame supports lights above each tank and a system of water tubing feeding into and out of the tanks. Neil brings me over to one where groups of baby kelp are stuck to rocks, their little fronds waving gently in the sloshing water.
And there's actually probably 10 to 50 individuals per rock when we first see them there. We ultimately will be planting 1 or 2 of these out per rock. So we're going to transfer some of them onto other rocks and then we plant them out.
So you just want 1 per rock because they're going to get really big?
Yeah, that's right. We only need 1 or 2, probably in reality 2 or 3 even. One will survive, the other ones won't, but yeah.
And so would you have to do that by hand?
We'll do that by hand. In other words, you take an individual frond and you'll transfer it to the rock and tie it in place. So it's a bit labour intensive, but yeah, it's a kind of experimental sort of approach. Ideally you would have, if you could seed like 1 per rock, would be great, but you can't do that because they're microscopic, so you've got no, you don't have that choice. You've got to let them seed naturally onto all the substrate that's available and then try and get that number of sporophytes sort of right for the number of rocks you've got there. It's too hard to sort of to judge that, so yeah, you thin it out as best you can and then maybe manually thin it out afterwards.
It's like planting your carrots. You
I
just throw a bunch of seeds and they come up and then you thin them out.
Well, you can, exactly, you can pick them off the rocks, you remove the holdfast very carefully and can then tie it manually onto, you can see it there quite clearly, you can tie it manually onto the rocks. That's one approach, and that string is a biodegradable cotton, so that breaks down, leaving the seaweed behind attached to the rock.
They look like almost like little parcels, the way that they're tied up.
Like little presents.
Yeah, like little gifts. Yeah.
Something like that. Well, that's what we hope, isn't it? They're a gift to Wellington Harbour. But as you can see, there is a lot of work involved in getting the conditions right. The important ingredients for the seaweeds are water motion, light. So these are grow lights. Nutrients in the water, we add nutrients to the water. So those are the three main things, and trying to keep the water as sterile as possible within reason.
And you've got like a one bucket Wellington fountain situation going on here.
That's where it came from. But that idea, I remember I was playing around with this idea 20 odd years ago with buckets and seaweeds and measuring growth rates and all the rest of it. There's no question it definitely helps. And when you think about the environment that they come from, the water motion, turbulence is really, really important for their health and their life history. So yeah.
And so that's introducing every now and again. That bucket tips over and pours a whole bunch of water in to mix everything up.
Exactly. So it just gets, and you can see if you look at a frond down there, when the bucket tips, you watch the effect that it has on it. That wave propagates through the whole tank and just gives it a good mix-up. So you've got nutrients in there, but if you, for example, didn't have any water motion, if the water was completely still, you get what's called a boundary layer forming around the seaweed, and there's a localised depletion of nutrients. So by mixing the water up, you're giving good access to nutrients for all the seaweed. So it's enhancing growth basically.
And it's all the macrocystis here. It's all the giant kelp that you're focused on.
All macrocystis, yep. And it started on the other side in the algae lab, in the incubator. So over there is kind of like the prenatal, I suppose. And then here is kind of like kindergarten or the preschool or something like that. Yeah. Out there is where they want to be, of course. So that's the next step.
Marine aquaculturist Siddharth Ravishankar is there looking after the kelp through each step. From prenatal to kindergarten to graduation out into the ocean.
You're involved with the whole process essentially, right from the time it's microscopic, still in the parent plant, so to speak. Parent's probably not the right term, but essentially the parent plant, all the way to get them to the size that they are right now. So it is really rewarding to know that your work is actually being used in a practical sense and is actually leading to something. I've also outplanted a whole bunch of them last year. We've done a few more this year as well, and last year's batch has gotten really big now, so they've all exceeded like 4 meters in length that we planted out last year. Yeah.
Have you gone to see them?
Yeah, quite regularly we have. So for a while we were recording the growth rates every fortnight. It's a bit trickier now since we've got 2 sites to work with at the same time, plus weather conditions. But we do check on them very regularly. Yeah, and still alive, or most of them are. Some of them got hit a little bit hard by the summer heat wave over the start of the year. But everything that's survived has grown really, really well.
And there are more plants, with some different conditions to be tested.
We're still outplanting some of the ones inside the large tanks over there. So those ones we have just been carrying them from the shore and then putting them down in certain locations at Versa Bay. There's another whole batch inside there. When the time is right, Neva's going to be planting those out. So those ones will be going a bit deeper than the Versa Bay batch, and we plan on essentially using a sort of marine cement to put them at the bottom of the ocean to keep them in place. So there's going to be a lot more planting coming up,
Which brings us back to Versa Bay, where Lee Rauhina August has just pulled up.
Kia ora mai tātou, ko Lee Rauhina August tōku ingoa, ko hau te kaiwhakahaere Māori, mō la Rimurimu. E hara tēnā tōku mahi noiho, kua haua no te māngai mo Taranaki wānau ki te upoko o tika. No reira tēnā tātou katoa.
Kia ora.
Kia ora.
Tēnā koe. And you have just shown up in this black ute with a whole bunch of fish boxes in the back.
I have.
What is inside the boxes?
So inside the boxes are some of our Rimurimu, kakauroa, macrocystis babies that will be planted out today here at Hutiakākariki, Versa Bay.
And as part of your involvement with the project, you're also helping with the tikanga around the plant out. Can you talk me through what that involves?
So as part of my role as wakahaere Māori is to ensure that we have tikanga, we have protocols in place. So that involves karakia. So this morning we had karakia as we were packing these taonga, and then we had karakia as we came on our journey here to Hutiakākariki to ensure their safety and to acknowledge the fact that they've grown in the lab for us, and then they're going to go out into the sea and help to restore our harbour.
And for you, what do you see as the benefit of a project like this?
So for me as mana whenua, as Taranaki Wānui, wanting to ensure that our harbour is healthy as it can be, and to ensure that should we potentially need to think about food sovereignty in the future, food sovereignty in our harbour at the moment is near on impossible. But by growing these taonga and by creating a better environment and ecosystem in our moana, we know that we're going to be able to look after those species that we will rely on to eat, and also the ones that we eat now like kina and paua that use these as habitat.
Can you show me some of the
I can,
Rimurimu?
yeah. So you'll see in here what we've done is we actually got together about maybe a month and a half, 2 months ago, and we actually tied some very tiny blades of macrocystis to these rocks here. And in the last 4 or 5 weeks, it might even be 6, you've seen how much it's grown. Some of them were probably about 2 centimetres when we tied them on. Kind of fiddly, and once you figured out how to do the string and what they needed to, to actually get to this level, they've been in the tanks, they've been grown, they've been looked after by Siddharth and the Niwa team. And then look at us, we get to come out here as victors and show that it works, and we're putting them back into the harbour.
Yeah, and some of them are like 10, 12 centimetres long now.
Indeed.
They've got that beautiful frond shape. And to think that they're going to grow into the massive kelp, it's pretty cool.
It's very cool, and we know that the harbour's a very vibrant place, and so of course some of them will survive and some of them won't, and that's why we have to keep on putting so many out, because we want to make sure that as many of them as possible can grow into those beautiful big macrocystis.
It's one of the things that I love about snorkeling around New Zealand is the kelp forest. When you snorkel through a kelp forest, it's so gorgeous.
It is, and of course our people always talk about them. They've been like a safety line, if you will. When our people have been out gathering kaimoana, you can hold on to the macrocystis to ensure you're not taken away by the tide. So it's seen as something that helps to protect us.
And I suppose it's home for so many different creatures as well of the ocean. So yeah.
Absolutely, yes. And without it, where would we be? And you're right, it's so beautiful just snorkeling around, and it's a privilege. Not many people across the world get to just go out for your casual snorkel and you're in these amazing kelp forests with animals everywhere.
How many of these little baby kelps tied to rocks with string do you have in the back of the truck?
So we've got 120 here today, and they will be planted out in 3 different plots, as I understand. And we're really excited for it.
Yeah, wish them good luck in their new home.
Absolutely. And as I say, we had our karakia, and then I drove very, very slowly with them, knowing that we've got some very precious taonga here in the back. That's going to be important for all of us. Aha ko wai no here, no matter who you are and where you're from.
Today the planting is being done by Rimurimu staff, including Zoe and Siddharth. But 2 rangatahi from the local kura kaupapa Māori o Ngā Mokopuna, have called down to talk to me about their experience of being kelpers.
Ko mihi rangi ko hatu toku ingo. He uri tēnei no Ngāti Raukawa, Ngāti Tūwharetua, Ngāti Maniapoto. E kura ana ana ki te kura kaupapa Māori o Ngā Mokopuna, he tautoko matahi au.
Kia ora, ko tūtei Dimasha tōku ingoa. He uri tēnei no Ngai Tūhoi, Roatoki, Ngāti Kaungunu ki Wairarapa hoki. E kura ana ki te kura kaupapa Māori o Ngā Mokopuna. E tau tikau au.
Both Mihirangi in Year 11 and Tutahi in Year 10 have been involved in the project for a while now, learning about the different species of kelp, gaining skills, and helping more and more with the restoration here at Worcester Bay.
I think most of us just love exploring the ocean, and that's why we picked up a hobby of being some kelpers. We've also learned amazing skills for over this time that's actually helped us and grown us into actually wanting to explore more out into the ocean. So, yeah.
Did you always have a tight connection with the ocean, like a bond with the ocean, or did that grow out of the project?
I think it's 50-50, but when I started deep diving into it, I've just realised how beautiful the ocean is, and we need to really take care of it. And I think that's why most of us has actually become kelpers, so that we can restore the marine life that's in the harbour here, because they've always been kaitiakis of the harbour.
And because we kind of connect, we weave our mātauranga, our knowledge and tikanga Māori into Love Rimurimu. I think it's a big part for us living here, just on the shore over there. It's important for us to be kaitiaki of these waters because, it's kind of in our whakapapa and it's important to take care.
Through Love Rimurimu, they've both done a freediving course with instructor Sasha. They spent some time in the pool, got used to weight belts, and learned some tips to keep themselves calm so that they can stay underwater longer.
She told us to sing a song while we're underwater, just to get your mind off the fact that you're deep down in the ocean. It's a whole new experience.
So you're just singing a song in your brain?
Yeah.
What's your go-to diving song?
Probably Just Keep Swimming, just from Nemo. It's like a really good push.
Yeah, that's a good song.
Yeah.
The skills they've gained helps them to be better kaitiaki, or caretakers, Tutahi says. And kayako Renee Campbell agrees. The hands-on aspect has been really helpful for her students. Tutahi brings me down to the water's edge to point out where the planting sites are.
You can't see it from the shore, but if you say to get in and you go really deep down, you can see a bunch of rimurimu down there. That's near the rocks that were planted actually. And I think it's really deep down, and that's where the skills for the course came through, that we can just breathe properly and just get it down there. And this is the outcome of it. So it's actually really beautiful to see. But sometimes things go wrong, and the rimurimu could get chomped on by a crab or anything, just marine life killing it. That's why we go out and surveil it, so that we can do it right and hopefully see some rimurimu grow.
For Kai Whakahaere Māori Li Rauhina August, this is a key part of the project.
We're so proud. Our karaua actually named that kura, and Ngā Mokopuna, of course, is named after one of our harbour islands over here. And when we see these wonderful young rangatahi, these taiohi, our leaders of tomorrow, with passion, doing this mahi, not only thinking about the research, but actually planting them out, learning to be divers. It's an incredible future for us, and we're really proud. Some of those children from the kura come from our iwi, and some of them don't. But to us, it's about building knowledge and capacity, and knowing that our future is in really great hands with those kids.
Zoe Studd says it's all about that goal of ensuring the project is community-driven and based.
I would love to see lots of people connected to this project and really passionate about their seaweed forests in the same way. And I can already kind of feel that change in the community in some ways. I have a lot more conversations with people about what they're noticing, about being in the ocean, about an appreciation for our seaweed forests and everything that they provide. And so through that journey of learning and connection, I would like to see, our efforts in restoration scale up, and for the community to become really central in those restoration efforts. And I'd also really love to see some wider conversations about how we improve what's going on inside our harbour. And those conversations, they are at a central local government, iwi hapu whānau. Those are the places that those conversations need to be had about what sort of protection, what sort of work needs to be done on land to make sure that our harbour can thrive into the future as well.
Thanks to Zoe Studd, Dr. Christopher Cornwall, Dr. Roberto Darquino, Neil Barr, Siddharth Ravishankar, Li Rauhina August, Mihirangi Kohatu, Tutahi Devonshire and Renee Campbell. This episode was produced by me, Claire Concannon, with help from Phil Vine and Ellen Reichertz. Sound engineering was by William Saunders, and Tim Watkin is executive producer of podcasts and series at RNZ. Our webpage is at rnz.co.nz/ourchangingworld, where you can find out more information, see some photos, and you can sign up to our monthly newsletter. If you've got feedback for us, you can email ourchangingworld@rnz.co.nz. Tēnā koe I whakarongo mai. Thanks so much for listening to this, our first new episode of 2024. We want to make it a big year for the show, so if you enjoy Our Changing World, please help us spread the word. Ko Claire Concannon aho, have a great week. Kia pai, te wiki.